you ever tried engulfing pizza as a whole? Well, unless your mouth is ginormous, it's technically impossible.
That's why you should cut it into pieces, partial pieces. The same concept can also be applied to rational polynomials, but here we call them partial fractions.
So, how do we expand this expression? You can use cross-multiply techniques and tada! The partial fraction method let you break up the complex expression into simple form so that you can integrate the function.
Before we continue, we need to know the three types of partial fractions. The first type of partial fraction is the linear partial fraction. The second type will be the quadratic partial fraction, followed by the third type, improper partial fractions. In this video, we will be demonstrating how to integrate all three types of partial fractions. So first, we will demonstrate to you how to carry out the integration of linear partial fractions.
Let's start with this question. Since we cannot directly integrate the expression, we must first transform it into a partial fraction. Firstly, factorize the denominator. Using the linear factor rule, we will get. After that, multiply the whole expression by x minus 7, x minus 3 to get. Substitute x equals to 3 and x equals to 7 into the expression to find the values of constants a and b. So from the question, we will see that when x equals to 3, b equals to negative 5, and when x equals to 7, a equals to 9. Hence, you can see that, which is simpler to integrate than the original equation.
Now let's try another question. Just like the last one, the first step is to factorize the denominator, in which you get 2x minus 1 and x plus 3. Through partial fractions, you can separate the denominator like so. Then, multiply both sides by 2x minus 1 and x plus 3. Substitute x equals to 1 over 2 and x equals to negative 3 into the equation. Upon doing so, you will get a equals to 2 and b equals to 1. As you can see, this is a lot easier to integrate than the more complex equation previously. Now the answer for this integration is ln modulus 2x minus 1 plus ln modulus x plus 3 plus c.
Now, you can try these two questions. Feel free to pause the video and the answer will appear moments later.
Let's say you have an equation like so. To expand this into a partial fraction form, you will probably get a over x plus b over x squared and so on until you obtain e over x to the power of 5. As you can see, in this case, just keep increasing the power of the polynomial until it reaches its limit. Here's a simple example of the integration of 2x plus 5 over x squared dx. Let 2x plus 5 over x squared equal to a over x plus b over x squared. In this case, multiply a over x by x. The reason is so that the denominators match. After doing this, it will give you ax plus b over x squared. Like the previous example, you need to compare the numerators, which will give you a equals to 2 and b equals to 5. The integration of 2 over x plus 5 over x squared dx will eventually give you 2 ln x minus 5 over x plus c. Next, we'll be showing you how to integrate quadratic functions. You see, the main difference between quadratic functions and the average linear function is that some factors of a polynomial in a quadratic function are irreducible quadratics. For example, if you see this integration of this polynomial, it has x squared plus 1. And this x squared plus 1 is called an irreducible polynomial, which means it cannot be further factorized. To solve this problem, we should introduce an extra variable to the numerator, like this. As you can see, the first part is the average a over x minus 1. But then, in the second part of this quadratic function, there will be a bx plus c over x squared plus 1. Like a linear partial fraction, we should always first break it up and then cross multiply. After cross multiplying, we have to compare the numerator, and in this case the numerator will be negative 4x, and we need to compare it to a plus b x squared plus c minus b x plus a minus c. We'll find that a will be negative 2, b will be 2, and c will be negative 2. All that remains is to substitute these values into the polynomial, and there you're going to get negative 2 over x minus 1 plus 2x minus 2 over x squared plus 1. All you have to do now is to integrate this function like so, and you should get the final answer, which is negative 2 ln x minus 1 plus ln x squared plus 1 minus 2 tangent inverse x plus c.
Let's see this example. Let the equation be ax plus b over x squared minus 3x plus 3 plus c over x minus 2. Then find a, b and c. You will get a equal to 1, b equal to 2 and c equal to negative 1. From here, you can integrate this function easily, as you can solve the first two terms by splitting them into two terms, and you will get this.
Here are a couple more questions for you to try out.
Now we move on to improper partial fractions. Now these type of partial fractions occur when the highest degree of the numerator is more than or equals to the highest degree of the denominator. When this happens, it becomes improper. To begin integrating this, you must first perform long division. Take this question for example. You have x squared plus 2x minus 47 over x squared plus 2x minus 35. As you can see, the highest degree of the numerator and the denominator are equal, which is 2. From here, you get 1 minus 12 over x squared plus 2x minus 35. This part of the equation, you can perform partial fractions as you did previously on the last two lessons you learned. This one, in particular, is the linear partial fraction. So from there, you get a equals to negative 1 and b equals to 1. Now, as you can see, this is a lot easier to integrate. Once you integrate, you get x plus ln modulus x plus 7 minus ln modulus x minus 5 plus c.
Let's look at another question that uses the same technique that you just observed. In this question, you can see that the highest degree of the numerator is bigger than the highest degree of the denominator. So all you have to do is perform long division and you will get a new equation. From the new equation, you can see that the third term is 2x plus 20 over x squared plus 2x minus 8, and this is the term that you can perform partial fractions on. So from there, you will get a over x minus 2 plus b over x plus 4. Substitute x equals to negative 4 and x equals to 2 into the equation, and you will get a equals to 4 and b equals to negative 2. Hence, you will get 4 over x minus 2 minus 2 over x plus 4. You will get the final equation of x minus 2 minus 4 over x minus 2 plus 2 over x plus 4. Thus, it is easier for you to integrate the new expression, in which you get ta-da!
Hallelujah, guys! Here's your last question.
That's all from us today. So if you have any more questions to ask, please do consult your lecturer. Goodbye!